Hello, John. Hello, everybody. Welcome on Intel Cyclone V based RunBMC solution update. My name is Jan Sawinski. I'm software engineer working at Intel Poland. Today, together with Kasper Wszołek, our principal engineer located at the same site, we would like to give you an update about our FPGA based RunBMC solution. We would also like to mention about Lumin Zhang, our hardware design lead located in Shanghai. Lumin wasn't able to attend this event, but we would like to acknowledge her great contribution to model design and to this presentation as well. Okay, let's move to agenda. Next slide, please.
Okay.
Thank you. During this talk, we will do time travel to last year OCP Virtual Summit to give you background information how it started. Then we will share our motivation behind creating a FPGA-based RunBMC module. We will do a quick recap of first version and give update about changes introduced in second version of it. During this talk, we will also reveal some details about our RunBMC compatible integration platform and invite you for a demo. Finally, we will share our contribution plans. Next slide, please. Let's begin with a bit of history. Last year, during OCP Global Summit, we have presented our first version of Cyclone V based RunBMC prototype. Demo was showcased at Experience Center, where one could see our model integrated with reference server platform. Integration was done with help of Dropbox RunBMC Bring Up Board, because back then we didn't have RunBMC compliant platform. Since last year, we had continued to work on our RunBMC module, and now we are pleased to present the second version of it with improved compatibility to the latest RunBMC specification, which is 1.4.1. Next slide, please. Now I will give stage to Kasper, who will share some architecture details of our RunBMC module, motivation behind it, and changes added in second version.
All right, thank you, Jan. So I'd like to recapture what was the motivation to build a BMC solution based on FPGA SoC. So what we needed actually was a modular, reusable solution that could work across multiple platforms such as compute, storage, accelerator, switches, and could adapt to those specific demands of the platform without rebuilding the entire solution. We also needed some flexible form of management hardware and software that could be combined together and easily co-designed between what's in the hardware and what's in the software. We needed a scalable security architecture that allows for multiple security solutions to be executed and validated, and also a solution that is in line with OCP standards. So when we started the design, the RunBMC specification was just published. The conclusion was that the RunBMC standard, in a combination with FPGA-based management solution that is also a system on a chip with ARM cores capable to run OpenBMC firmware, checked all the boxes. That's why we decided that's what we want to do as a solution to those problems. As you can see on the diagram, we split the module into two portions. The management domain, here lives the Cyclone V SoC, that is a combination of FPGA fabric and ARM cores running OpenBMC firmware stack. And as you can see, the majority of typical hardware interfaces from the platform are going actually through FPGA fabric, which provides a lot of flexibility in handling multiple platforms with one module. And just by reprogramming the FPGA part, you can put the same module into a completely different subsystem. On the bottom, you can see the security domain. It says isolated MAX10 CPLD that from hardware design perspective can be a flexible security solution that can be used as a secure boot or platform root of trust. However, in our enabling of this module so far and the use cases that we did, we haven't enabled those fully so far, but from the hardware perspective, it's there. As you may notice, the FPGA-based BMC concepts is getting more traction, like LibreBMC project presentation in a server track this year is following the similar concept. So we also strongly believe that FPGA provides a lot of scalability and future-proof capabilities, which in combination with OpenBMC firmware creates a very powerful solution. And in this year's update from Intel, you will see a fully integrated Cyclone V RunBMC server platform with majority of OpenBMC firmware features enabled as well and presented in our demo videos, unfortunately, because we could not come. Next slide, please. So as for the Cyclone V RunBMC module that is called here V2, or we call it internally FAB2, we have improved compatibility with the RunBMC 1.41 standard. We have added a support for video port for VGA. And an interesting point here is that this VGA is fully driven by FPGA as well. Another change is the addition of secondary USB port. And also the Cyclone V supports actually 2 USB ports with a capability of on-the-go on each of those ports. So it also adds a lot of flexibility in switching of those functions. Our first prototype was also not meeting the PCB thickness tolerance of RunBMC standard. However, it was still fitting in the slot, but we really wanted to fix that in the FAB2 version, and that's what we are presenting now. And now Jan will talk a little bit more about our demonstration platform and our plans on the contribution of what we already done.
Thank you, Kasper. That was very informative, I think. Okay, so let's proceed to the next slide, please. Okay, so this year we are going to showcase our module integrated with RunBMC ready server platform. To be more specific, it is Cascade Lake ephemeral storage server designed with low latency and dual redundancy in mind. To achieve redundancy, this platform is made of 2 identical nodes, which eliminates single point of failure. As you can see in chassis, there are 2 nodes, 2 identical nodes located. Even if the failure will happen, node can be replaced without the interruption of provided services due to hot swappable design. On the other hand, low latency is achieved with the usage of 16 dual ported SSD. If you will look on the slide on the picture on the left, there we can see a single node. RunBMC is installed in the top right corner marked with the yellow rectangle. And there is on this platform there is another OCP project adopted. Namely, it is OCP NIC 3.0, which is located in the right bottom corner, just below the RunBMC. Using opportunity of having your attention, we would like to invite you to OCP Experience area for demo of our RunBMC module integrated with just described platform. During this demo, we will present our module in action. Using OpenBMC stack, we will manage server power states, follow host boot using serial overland and KVM. We will also look at Redfish and platform telemetry. Next slide, please. Okay, so let's move to our contribution plans. As announced last year, we are planning to contribute our hardware design files to OCP community. Contribution will include module schematics, PCB designs, and required files to start manufacturing. Additionally to hardware contribution to OCP, we are planning to open source firmware enabling layer on Intel's public branch of OpenBMC. Firmware contribution will add Cyclone V support in U-boot and Linux kernel. It will also provide configuration of on-module sensors, rules, and fan support. FPGA SoC IPs and related drivers are not planned to be part of this initial release, but we will provide project setup guidelines to help to configure FPGAs to allow OpenBMC boot. Next slide, please. That concludes our update. once again, feel invited to visit our hardware management station in experience area, where you can see the demo in form of video. Our initial plan was to attend OCP Summit in Fleur to give you live demo, but unfortunately it wasn't possible due to pandemic restrictions. Hopefully we will meet next year, and for now, in case of question, please contact us directly. Finally, stay tuned for design contribution, which will be available shortly. That's all from my side. Kasper, would you like to add something?
Yeah, so I would like to echo what Jan said. I would like to encourage you to go to the hardware management virtual station on the website, on the Virtual Summit website. There's this CycloneV RunBMC demo in the chassis that we just presented. Also, if you saw yesterday's keynote by Zane Ball from Intel, you could spot a CycloneV RunBMC on top of our DCSCM 2.0 module that we are also working on. We also provided 2 demo videos in the same location showing a lot of details of this unique combination of DCSCM standard and RunBMC standard on one module. You can find it all in the hardware management virtual station on the OCP website. So enjoy the videos on the website and feel free to follow up with us over the email or over OCP. We will be happy to answer all of your questions.
Okay, thank you, Kasper, Jan. Hope you can be with us next year.
Yeah, hope to meet you in Prague, in Czech. It's really close to us.
Okay.
And it's a beautiful place. I encourage everyone to go there and have a beer with us. I'm looking forward to that.
Okay, thank you, guys.
Thank you, John, for your support.
Thank you.